Hello. Today, we will present to you about implementation of array data structures with Baldorado Jan Mark, Bautista John Fonzy, Besin Elijah, Racelis Winston Hector, and Sayno Vincent Paul. Data structure in Python. An array is a fundamental data structure available in most programming languages, and it has a wide range of uses across different algorithms. Array consists of fixed-size data records that allow each element to be efficiently located based on its index. Because arrays store information in adjoining blocks of memory, they're considered contiguous data structure as opposed to a linked data structure like a linked list, for example. Um, um, the important terms to understand the concept of array are as follows. First, element. Each item stored in an array is called an element. Second is index. Each location of an element in an array has a numerical index which is used to identify the element. And this is the array representation. Array can be declared in various ways in different languages. An illustration is given below. So this is the illustration. Array representation. The following are important notes to be taken into account. Index starts with 0. Array length is 10, which means it can store 10 elements. And each element can be accessed via its index. For example, we can fetch an element at index 6 as 9.
Basic operations supported by an array are as follows. Number 1, traverse. Print all the array elements one by one. Number 2, insertion. Adds an element at the given index. Number 3, deletion. Deletes an element at the given index. Number 4, search. Searches an element using the given index or one by the value. Number 5, update. Updates an element at the given index. Type codes are the codes that are used to define the type of value the array will hold. Some common type codes used are as follows. Type code B represents signed integer of size 1 byte. The uppercase B represents unsigned integer of size 1 byte. C represents character of size 1 byte. L represents signed integer of 2 bytes. The uppercase I represent unsigned integer of size 2 bytes. F represent floating point of the size 4 bytes. D represent floating point of size 8 bytes. An example of array in Python with its output. Um, Before looking at the various array operation, this is an example of array 1. When we compile and execute this program, it produces the following result, which is 10, 20, 30, 40, 50. Accessing an array element. We can access the element of an array using the index of the element. This code shows how to access an array element. When we compile and execute this code, It produces the following result, which is shows the element is insert at index position 1, which is 10 and 30. Insertion operation in array adds an element at the given index. Insertion operation is to insert one or more data elements into an array. Based on the requirement, an element can be added at the beginning, end, or any given index of array. Here, we add a data element at the middle of the array using the Python inbuilt insert method. When we compile and execute this program, it produces the following result, which is shows the element is inserted at index position 1, which is 10, which is 16. This is insert 20, 30, 40, 50. Deletion operation in array deletes an element at the given index. It refers to removing an exacting element from the array and reorganizing all elements of an array. Here, we remove a data element at the middle of the array using the Python inbuilt remove method. When we compile and execute this program, it produces the following result, which it shows the element is removed from the array. Next, search operation in array. Searches an element using the given index or by the value. We can perform a search for an array element based on its value or its index. This example of search operation in array. Um, we search a data element by using the Python inbuilt index method. Update operation in array. Updates an element at the given index. It refers to updating an existing element from the array at a given index. Here, we simply reassign a new value to the desired index with only one update. When we compile and execute this program, it produces the following result, which shows the new value at the index position 2, which is 10, 20, 40, 50. Next.
So here are the examples of array data structure. The first one is list mutable dynamic array, tuple immutable containers, array.array, basic type arrays, string immutable arrays of Unicode characters, bytes immutable arrays of single byte, and the last one is byte array, mutable array of single byte. So the array data structure. The first one is the list mutable dynamic array. Lists are a part of the core Python language. Despite their name, Python's lists are implemented as dynamic arrays behind the scenes. This means lists allow elements to be added or removed, and they will automatically adjust the backing store that holds these elements by allocating or releasing memory. Next one is the tuple immutable containers. Tuples are a part of the Python core language. Unlike lists, Python's tuple objects are immutable. This means elements can't be added or removed dynamically. All elements in a tuple must be defined at creation time. Just like lists, tuple can hold elements of arbitrary data types. Having this flexibility is powerful. But again, it also means that data is less tightly packed than it would be in a type array. So the tuples are a part of the Python core language. And just like lists, tuple can hold elements of arbitrary data types. Having this flexibility is powerful, but but it also means that data is less tightly packed than it would be in a type array.
So the next data structure is array.array basic typed arrays. Arrays created with the array.array class are mutable and behave similarly to lists, except for one important difference. They are typed arrays constrained to a single data type. Because of this constraint, array.array objects with many elements are more space efficient than lists and tuples. The elements stored in them are tightly packed, and this can be useful if we need to store many elements of the same type. So the array.array data structure is very identical or similar to list arrays. The only difference of array.array to list arrays is that this is typed arrays and list arrays are changeable as opposed to array.array, which is only restricted to one data type. Next. The next array data structure is string immutable arrays of Unicode characters. String objects are space efficient because they're tightly packed and specialized in a single data type. If you are storing Unicode text, you should use them. Because strings are immutable in Python, modifying a string requires creating a modified copy. The closest equivalent to a mutable string is storing individual characters inside a list. String is an immutable array of characters to store textual data as Unicode characters. Also, it is a recursive data structure. Each character in a string is a string object of length 1 itself. So str, short for string, is another fixed or unchangeable array that stores all data as Unicode characters. String array data structure is ideal or good to use if you are planning on storing Unicode text as it works best in a given task. Next.
Bytes, immutable arrays. Bytes, immutable arrays of single bytes. Bytes objects are immutable sequences of single bytes, integers in the range of 0 and 256. Conceptually, they are similar to string objects. Like strings, bytes have their own literal syntax for creating objects and they are space efficient. Bytes objects are immutable, but unlike strings, there's a dedicated mutable byte array, data type called byte array that they can be unpacked into. So, sa example, we have a variable arr is equal to bytes function and a sets of number which is 22, 30, 10, and 6. So we just print out the variable with parameter of 1, which is 30. So kung maalala nyo na pag magbibilang tayo ng parameter, lagi magsisimula sa 0. So yung 1 is yung number 30. And the next is we just print the variable na may output na b apostrophe x16 x1e and 06. So bakit naging ganyan yung output? So bytes function just transform the sets of numbers into a sequence of bytes. Next is variable arr with parameter 1 is equal to 25. Error because bytes object does not support item assignment. Next is delete function. We use delete function to a variable arr with parameter of 1. Error because bytes object doesn't support item deletion. Last, we use byte function and 0 and 2206. Error because bytes must be in range of 0 and 256. Next. Byte array, mutable arrays of single bytes. The byte array type is mutable sequence of integers in the range of 0 and 256. They are closely related to bytes object, with the main difference being that byte arrays can be modified freely. We can overwrite elements, remove or add new ones. The byte array object will grow and shrink accordingly. So, sa example, merong variable arr, byte array function, and a set of numbers which is 22, 30, and 6. We just print the variable na may output na byte array function and open parenthesis b apostrophe x16 x1e and x06. Next is variable arr with parameter 1 is equal to 25. Nag-work na siya unlike kanina sa bytes function. Next is delete function to a variable arr with parameter 1. Nag-work ulit siya na may output na byte array open parenthesis b apostrophe x16 and x06. So nag-work siya na-remove yung byte form ng number 30. Next is variable arr parameter 1 is equal to 2206. Error because byte must be in range of 0 and 256. Next is variable arr1 is equal to Sarah, which is a string. Error because string object cannot be interpreted as integer. Lastly, bytes function to variable arr na may output na b apostrophe x16 and x06 x1b. So bytes array function transform sets of number into a sequence of bytes. So the main difference is bytes function is cannot be modified, while byte array function can be modified freely. We can overwrite elements, remove or add new ones. That's all.
So, dito na po nagtatapos yung report namin. Thank you for listening.